Hello students, in this video I will go through exercise U5A06B where I will be applying concepts of sine, cosine, tangent to solving for sides of triangles or solving for ratios of sides of triangles. Let's take a look. Alright, question 1. You're presented with two triangles here, and it's telling you that if tangent of z is equal to 1/2, hi is equal to 3, then find ij. Notice that you're given two triangles here, and you're told that tangent of z is equal to 1/2, which means that the ratio of these two sides will be 1/2. Notice that another piece of information is given, and that is this angle over here, angle x, is congruent to that of angle h. Well, if that's the case, and you have I and y are 90 degrees, then it can be concluded that angle z, which I'm coloring green, is going to be congruent to that of angle j. So we're actually going to take advantage of this situation here to find out what ij is. Well, that's because the two triangles are therefore similar. Okay, so triangle XYZ is similar to triangle HIJ. And because of this fact, since tangent of z is equal to 1/2, then we can say tangent of j is also equal to 1/2. And since tangent of j is equal to 1/2, and I'm given hi is equal to 3, and I don't want to call ij here x, then I can say 3 over x is equal to 1/2, because opposite over adjacent is equal to tangent of j. And then I can cross multiply, and my conclusion is that x is equal to 6, or ij is equal to 6. Okay, moving on. If tangent of r is equal to 1, what must be true about PQ and QR? Tangent of r is equal to 1. Well, if that's the case, tangent of r is equal to 1. What that implies is opposite over adjacent, PQ, over QR, is equal to 1. And the only way that that is true is if PQ and QR are congruent. Or in other words, these angles over here must be 45 and 45. All of those things are true. Alright, moving on. Alright, so very similar to question number 1, and that is you're presented with two similar right triangles, because I see here N and C are congruent, A and L are congruent. So again, ABC is similar to triangle LMN. And you're asked to find out what are the following things. Sine of so sine of B is equal to sine of which angle? So if you're asked to find out what sine of if sine of B is going to be equivalent to which angle over here, then we can conclude that sine of B is equal to which angle? Sine of M. We can also conclude that all of these things are going to be true, that Ln over Mn will be equivalent to AC over BC. And then we can make similar arguments about the other things. So cosine of c will be equivalent to cosine of n, which will be equivalent to, so cosine of c is AC over BC, which is also equivalent to ln over mn. I wrote it backwards compared to what I have over here, but that's okay. I think you guys got the idea. And then tangent of b is equivalent to tangent of m, and tangent of b is equivalent to AC over AB, and tangent of m is equivalent to ln over lm. Okay, moving on. Okay, if sine of c is equal to 1/2, sine of c is equal to 1/2, EC is equal to 10, dB is equal to 1. So this guy here is 1, and EC is equal to 10. Okay, find AE and DC. AE and DC. All right, so if sine of c is equal to 1/5, and sine of c is equivalent to the ratio of opposite to hypotenuse. So that would be dB over dC. dB over dC. So dB is 1, and dC we don't know. Let's call dC something. Let's call it x or something, right? So then if I solve for x, I can see that 1/5 is equal to 1 over x, or in other words, x is equal to 5. Since EC is equal to 10, then I know that ED is also equal to 5. Right? So ED is equal to 5, as well as DC is equal to 5. All right. Find AE. So since we're talking about a similar triangle here, and we can actually solve this in a couple of ways, we know that the scale factor, okay, between the smaller triangle and the bigger triangle is a factor of 2. So therefore, we can even conclude that AE must equal to 2. And if that confuses you, right, another way that you can think about this is sine of C, again, is equal to 1/2, which is equivalent to AE over EC. This is another way of thinking about it. So EC is 10. And, oh, I'm sorry. This is not 1/2. It's 1/5. That's why I'm looking at this strange. So then AE, what would AE equal to? If I cross multiply both sides by 10, AE, again, is equal to 2. Okay. Cosine of D is equal to 1/2. Cosine of D is equal to 1/2. So that means, again, cosine of D is equal to 1/2. So that would mean that CD over ED is equal to 1/2. And since I know ED is equal to 5, I can say 1/2 is equal to CD over 5. I can then solve for CD. CD is equal to 5/2. Okay, and since I know that the triangles here, D, okay, must be congruent to angle ACB, because I have angle E is congruent to angle A, right? The leftover angle, therefore, must be congruent to the other leftover angle. All right, so with that said, and I know that BC is equal to 2, So I can say cosine of C is equal to, again, 1/2. And cosine of C is equal to BC over AC. And since I'm given BC is 2, I can say 1/2 is equivalent to 2 over AC. So therefore AC must equal to 4. And I need to find out what AB is. Okay, so since I know all these things now, right, that CD is equal to 5/2 and AC is equal to 4, and these are right triangles, we can use Pythagorean Theorem to figure out the rest. So AB right, AB squared plus AC is the hypotenuse, and BC is the other leg, so plus 2 squared is equal to AC, which is equal to 4 squared. So therefore, if I subtract both, if I figure this out, this is 16, this is 4, AB squared. Subtract both sides by 4, AB is equal to 12, or the square root of 12, or AB is equal to 2 square root of 3. And then lastly, I want to do something similar to find out what EC is. So since we know ED is 5, so we can say 5 squared is equal to CD, which is 5/2 squared, plus EC squared. So again, we're going to go through this. This is 25 is equal to 25/4 plus EC squared. Subtract both sides by 25/4, I get 75/4, okay, is equal to EC squared. Take the square root of both sides. EC will turn out to be 5/2 square root of 3. Okay? All right, moving on. Question 6. Tangent of A is equal to 3/2. So tangent of A is equal to 3/2. So since tangent of A is equal to 3/2, then I can say opposite over adjacent, so I'm going to call that x there, over x, and I can solve for x. Then find all remaining side lengths of A, B, and C. So I want to cross multiply. I end up with 3x is equal to 8, x is equal to 8/3. Since I know x is equal to 8/3, I can again use Pythagorean Theorem to say, oh, if this is 8/3, then I can say 8/3 squared plus 4 squared is equal to AC squared. So I get 64/9 plus 16 is equal to AC squared. 9 times 16, what is that? That is 144. So 64 plus 144 over 9 is equal to AC squared. Therefore, AC is equal to 144 plus 64, that's 208 square root of 208 over 9. And this is going to be 3, and then the square root of 208, what is that? That will be 2 square root of 52. Can we divide that for any further? Yes, we can. That would be 4 is divisible into 52 13 times. So we end up with 4 square root of 13. Okay, so AC is equal to 4 square root of 13/3. Okay, and did I solve for everything? I believe I did. AB is equal to 8/3. Okay, question 7. Triangle ABC is similar to triangle XYZ, and angle A and angle X are right angles. So I'm going to draw that situation. So A, B, C, and X, Y, Z, they are similar. A and X are right angles. Sine of B is equal to 1/3. So sine of B is equal to 1/3. YZ is equal to 4. What are the side lengths of XYZ? Okay, so side B is equal to 1/3, which means sine of Y is also equal to 1/3 because ABC and XYZ are similar, so therefore all the corresponding angles are going to be the same. So sine of B is 1/3, sine of Y is also going to be 1/3. So if I know sine of Y is 1/3, and let's say I'm trying to solve for this side here, let's call that n, right? So I can say sine of Y is equal to n over 4, and sine of Y is 1/3. So now I can solve for n. N is equal to 4/3. So if n is equal to 4/3, I can now solve for, let's call this side here m, right? So m squared plus 4/3 squared is equal to 4 squared. I'm going to square everything. So this is 16/9 plus 16 is equal to m squared. I'm sorry. M squared plus 16/9 is equal to 16. Subtract both sides by 16/9. M squared is equal to 144. I'm sorry. 16 minus 16/9, which is equivalent to 144 minus 16 over 9, and that would be equivalent to 128 over 9, or m is equivalent to, what is that, 128, is that divisible by 16? Let me see here. 128 divided by 16. Yes, it is. And it's divisible not only 16, but it's divisible by 64, of course. So 128 is, well, m's square root of 128 over 9, but it's also equivalent to 8/3 radical 2. So m, so in other words, not n, xz is 4/3, xy is equivalent to 8/3 radical 2. All right, moving on. Triangle ABC has a right angle at B, and cosine of C is equal to 2/3. PQR and ABC are similar. And it says cosine of C is equal to 2/3. So I want to call this C here, ABC, and PQR. So if C is the right angle, is C here, if I'm calling this C, then the adjacent side here, this is the adjacent and this is the hypotenuse. So AC over AB over BC will equal to 2/3, because cosine of C is equal to 2/3. If PQR and ABC are similar, and BC is equal to PR is equal to 5, BC is equal to, this is 5, and this is also 5. Okay, so that means that we can then say AC over 5 is equal to 2/3. So AC is equal to 10/3. If AC is 10/3, we can then solve for AB. AB squared plus 10/3 squared is equal to 25. AB is equal to 25 over, AB is equal to 25 minus 100 over 9, square root, right? So what would that be? So that would be 9 times 25 minus 100, 125 over 9. So that's square root of 125 over 9, which is equivalent to 5/3 radical 5. So AB is 5/3 radical 5. And since cosine of C is equivalent to cosine of R, we can say then 5 over QR is equivalent to 2/3. Cross multiply, we end up with QR is equal to 15/2. If QR is equivalent to 15/2, then we can solve for the other remaining sides. So QR 15/2 is equal to 5 squared plus PQ squared. I want to solve for PQ. So 15 squared is 225 over 4 minus 25 is equal to PQ squared. PQ is equal to 25/4 square root, which is 5/2. And no, I'm sorry, it's 125. So that means this is going to be 5/2 square root of 5, in other words. So PQ is equal to 5/2 square root of 5. And that's it.